In this video, I'm going to show you how to design and facilitate effective team application activities for your courses. Hi, I'm Daniel Peake, and I'm an educational developer from the Center for Learning and Program Excellence at Red River College. No matter how your course is set up, team application activities can make learning more engaging and interactive. In this video, I'll walk you through the steps to create an effective team-based learning experience so that your students can apply their knowledge in a collaborative setting. The first thing you need to do when designing effective team application activities is to understand their place and structure within the TBL model. Team application activities, or TAAs, are often considered the heart of team-based learning. They are the third phase of a team-based learning model. This follows after the readiness assurance process. TAAs are where students apply their foundational knowledge from the pre-class work and readiness assurance tests. In phase 3, they solve complex real-world problems in their teams. Your role as an educator during the TAAs shifts from delivering content to facilitating discussions and guiding the teams. TAAs should be characterized by the 4S framework. Understanding and implementing these 4 S's is crucial for creating engaging and effective application activities. Here are the 4 S's. Number 1, significant problem. The problem presented to the teams must be relevant and meaningful to the students, particularly to their future careers. This relevance is key to keeping students actively engaged and motivated to participate. Number 2, same problem. All teams must work on the exact same problem. This allows the entire class to participate in the same debate and discussion, rather than passively waiting for their specific issue to be addressed. Number 3, specific choice. The problem should require teams to arrive at a specific answer or choice, rather than being open-ended. The specific choice allows students to compare their answers to one another, and this facilitates healthy debate between the teams. Often, this specific choice is presented as a multiple choice question, which can be scenario-based or require interpretive or multilogical thinking. Simultaneous reporting. Teams must report their specific choice at the same time. This holds students accountable for their choice and encourages teams to both challenge each other's answers and defend their own. Now that you've grasped the core principles of TAAs and the 4 S's, it's time to start designing your own significant problem for your class. Designing effective TAAs is part of the backwards design process, where you start with the learning objectives and then create the application activities. Here is a suggested framework for designing a significant problem using a learning outcome from a course called Menu Management. Step number 1. Think about 2 or 3 common, meaningful problems faced by experts in your field. Align this problem with a specific learning outcome you want students to achieve. For example, one of the learning outcomes from the Menu Management course is analyze the factors contributing to increased food costs and reduce profit margins in a food service operation to identify opportunities for operational improvement. A little bit of a long learning outcome, but the common problem in the food business is managing food cost and waste in the kitchen. So carrying on with step number 1, identify typical data sets that experts in your discipline use to solve these problems, and how do these data sets contribute to problem solving. For menu management, we could use data sets such as temperature logs, supply order records, waste logs, inventory, prep lists, training records. All of these could help you solve this wicked problem of food cost in a kitchen. Step number 2, analyzing data completeness. Consider the challenges of working with incomplete or imperfect data in your field. How do experts typically address these issues? For example, challenges might include missing waste logs. There may be tools or measuring ingredients that are missing in the kitchen, and therefore chefs estimate, and chefs may adjust recipes based on their experience. So all these elements inject realism into the problem. Step number 3, assumptions in problem solving. Common assumptions that experts make when solving these types of problems. For example, managers in kitchens might assume that all logs are correct, all ingredients have been delivered, or all chefs are trained in reading standard recipes. Incorporating these assumptions makes the problem more interesting. Step number 4, craft the expert scenario. Using the core problem, the data sets, data completeness issues, common assumptions, you can now identify and craft the realistic scenario that requires students to perform the same type of analysis and judgments experts routinely make. Also, you need to choose the type of specific question that you want to make. You need to have these teams come up with a specific choice. So this could be a scenario-based, best or most questions, interpretive or multi-logical thinking questions. Here's an example scenario based on our learning outcome. The Winnie Pepper food truck is seeing increased food costs and reduced profit margins despite consistent sales. As the owner, the teams must identify the issue and implement a solution. They must justify their best choice based on the provided data. So in this scenario, you are presenting a question with specific choices, A, B, C, D, or E. You are providing relevant data sets. For example, you might be supplying a monthly ingredient food cost list, a daily waste list, or the high cost of ingredients that are frequently running out. Also, maybe some kitchen reports of inconsistent portioning. Large staff turnover might be an issue as well. This structured approach helps ensure your TAA problem is significant, realistic, and requires the application of knowledge in an expert-like way. Now you've designed your significant problem, it's time to facilitate the TAA in the classroom using the 4S framework. Good luck and thanks for watching.